Hi viewers, this is Arvind Subramaniam. Welcomes you once again. So today topic is about an Simatic Step 7 manager. It's nothing but a configuration and RLO edge detection of an schematic Siemens programming. So I'm just now going to open an Simatic Step 7 manager. It is taking a little bit time. So the version I have used is Simatic Step 7 version 5.5. I'm just going to file, close it. I'm just going to a file, new, and the project name title as age detection. Whatever the name you can give it as a project title, and OK. Now I'm going to double click on MP1 and go to a station address and station select as schematic 300. So now I'm going to program and configure it for an schematic step 7 300 variant PLCs. So double click on Simatic 300, a new window will appear. This is nothing but an hardware configuration. So there is some rules to be followed while your hardware configuration. The step 1 should be a rack. You need to insert a rack, after the power supply, and after that a CPU is compulsory. These three components are compulsory during a stimulation process. If you are going for a hardware real-time hardware configuration, you need to follow according to the hardware which you have used. So I'm just placing a rail, and now I'm going to place a power supply, a 5 amps power supply. After that, I'm just selecting a CPU as C12, C whatever maybe. Okay, so you can select a CPU particularly according to which you have used already in a field. So if you are programming for a particular PLC, you just choose the CPU. So that's all about these three components are enough during a stimulation process. Okay, so after that, go to a network configuration. Configure network. Okay. So just close all those external windows. I'm just going to open an Simatic 300 CPU 312C and source block and OB1. It's nothing but an organization block, and select a programming language as ladder. I'm just going to choose an ladder programming language and go OK. Now you can see that the programming window will appear. Network 1 is nothing but an rung. Each rung is said to be as a network. So I'm just going to place a contact as normally open contact. After that, a normally closed contact, and one more output. So this is nothing but a DOL concept. For input addressing, I0.0 is an addressing for an schematic step 7 manager. So in Siemens, you need to give an input address as I0.0, I0.1, I0.2 likewise. Okay. So I'm just going to use two input as start stop, and output will be an Q0.0. Q0.0. Okay, that's all about the input and output addressing. So I'm just going to connect it. Okay, that's it. So if you need to give an any command, any topic name, any component name, you just go to an edit symbol, address, command as start, data type is a boolean type, and also you need to give an symbol. Okay, so symbol as I0.0. Okay. In the same as it as I'm going to give an stop command as an I0.0. So I'm just giving an stop as a command for an I0.1 address. After that, I'm just going to give an name the output as motor. Add symbol. Okay. So that's all about the basic DOL concept working in a Simatic Step 7 manager. So I'm just going to turn on a stimulator. You need to turn on the stimulation. And it should be in run mode. Download the program and enable the monitoring mode. The monitor mode should be in on, then only you can see either the input is turning on or off. So run the program, and I'm just turning on an I0.0. You can see that the output will get turned on, and if I'm turning on the I0.1, the output will get turned off. So that's all about the basic DOL concept. So in the same concept, I'm going to use an RLO edge detection. Before going to an edit mode, just stop the programming and turn off the monitoring mode. So I'm just going to show the exact same condition for an RLO edge detection. You can see that what is the purpose of RLO positive and negative edge detection. So I'm just going to use an input, and after that input I'm going to use a set coil as an output. So I'm going to BitLogic's set coil and insert the rung, another one rung, and input address as I0.0. So I'm just going to place a normally open contact and reset coil. Sorry, not this positive edge, just P. That's enough. So this is the RLO positive edge detection, and select N, which is a negative edge detection. So negative and positive edge detection is nothing but 0 to 1 and 1 to 0 status. So, okay. So I'm just going to give an memory address as an address for the positive and negative edge detections. M0.0, M0.1 as a addressing, and output will be as Q0.0 for both the output coils, as well as in set and reset. So that's all about it. So positive edge will detect when input changes the status from 0 to 1, and negative edge will detect a signal when the input goes from 1 to 0. So I'm just going to download and turning on the monitoring mode and stimulator running the program in a stimulation. So now you can see that if I turning on 0.0, the output will get turned on, and if turning on a 0.1, the output will get turned off. So thanks for watching video. If you have any doubts, please go to the comment section and comment below. And if you like this video, please share with your friends and colleagues. Thank you. Thanks for watching video.